Once you have decided that cellular is the right connectivity choice, the next question is, which cellular radio technology? There are 5 major options for IoT today: LTE-M, NB-IoT, higher category standard 4G LTE, 5G, and the new 5G RedCap. Soon you will be able to distinguish between all 5, understand their design goals, and identify the applications each one targets. Let's start with the big picture. These 5 technologies ranges from lowest power, lowest throughput connectivity to higher performance, more capable, but more power-hungry options. NB-IoT, or narrowband IoT, uses just 200 kilohertz of bandwidth, the narrowest channel of any cellular technology. It was designed from the ground up for stationary devices that send small amounts of data infrequently. Think smart meters reporting hourly readings, soil moisture sensors updating every few hours, or parking space detectors. NB-IoT achieves peak download speeds of about 170 kilobits per second and has relatively high latency, typically 1.6 to 10 seconds. It does not support mobility, or handoff between cell towers, and cannot carry voice. What it does offer is exceptional indoor penetration and the potential for 10+ year battery life on small cells. LTE-M, technically called Cat-M1, uses 1.4 megahertz of bandwidth, about 7 times more than NB-IoT. It was designed for IoT devices that need more capability, faster data rates, up to about 1 megabit per second, lower latency, around 50 to 300 milliseconds, full mobility with handoff support, and even voice over LTE. It was first widely available in North America. Standard 4G LTE, categories like Cat 1, Cat 4, and higher, and standard 5G offer significantly more throughput, up to 150 megabits per second downlink for Cat 4. They support full mobility, low latency, and can handle demanding applications like streaming video from a security camera, running a mobile router, or connecting an industrial gateway that aggregates data from dozens of local sensors. The trade-off is higher power consumption and higher module cost. Standard 4GE and 5G encompass the most widely deployed and available radio access technologies, and should be preferred for applications that can be designed around their power requirements, as these technologies will have the most coverage. 5G RedCap, reduced capability, standardized in 3GPP Release 17, bridges the gap between high-throughput 5G new radio and low-power LPWAN technologies. It delivers the right-sized connectivity for industrial sensors, wearables, and smart cameras, with approximately 65% lower modem complexity and native support for network slicing. RedCap limits bandwidth to 20 megahertz compared to 100 megahertz for standard 5G new radio, reduces antenna count to 1 to 2 receivers, and uses simpler modulation. Peak speeds reach approximately 220 megabits per second downlink, with latency comparable to standard 4GE. RedCap also inherits advanced 5G features like enhanced positioning, centimeter-level accuracy by aggregating signals across frequency layers, and 5G LAN for factory floor communication. Release 18E RedCap goes further. Enhanced RedCap caps the peak data rate at 10 megabits per second, both DL and UL, and typically uses a single RX antenna. This targets the direct replacement of LTE Cat 1 and Cat 1 BIS for the simplest IoT devices, basic trackers, smart meters, and environmental sensors. NB-IoT is for stationary, low data, long battery life devices. LTE-M adds mobility, voice, and faster speeds for trackers and wearables. Standard 4 and 5G handle high throughput and offer wide coverage. 5G RedCap brings 5G capabilities, network slicing, enhanced positioning, higher speeds to IoT at lower complexity and cost. Next, we will explore the engineering trade-offs between these technologies in more detail.